say it in the way that you can understand it. But the main thing is that today's lesson is one that I want you to guide. In other words, I'm not going to tell you everything to do. I'm going to do a little experiment, and then I want you to talk about it and try to figure out amongst yourselves with your pair partners or with a group what is actually going on. You might not know, and then we'll talk about it. So I have a pie tin that you make pies in. I want to get this where everybody can see it. So can you scoot out a little bit? I'm going to put this right in the middle.
We should do a circle.
What a great idea.
Maybe a semicircle.
That's a good
is
idea.
Great idea.
Shh, gently.
So that you can all see equally. And this is just regular milk in here. I put it in a cream bottle, but it's just milk. Today we're going to be talking about the properties of liquids. What makes a liquid different than the floor? What makes a liquid different than the air? There's different kinds of stuff in the world, and we're going to be talking about the stuff called liquid. What are some other liquids you can think of?
I did that in the science fair.
Orange? Yes, you can make orange liquid. Water is a liquid, sure. Juice is a liquid. Soda, you guys got it. So you understand what it feels like. These are food colorings. I'm just going to put a little drop here and a drop there. They're not really going to do anything right now. We're going to make them do something really interesting though. Right now it's just a drop, and it just stays in the milk, and it doesn't really do much of anything. So a little red, a little green, a little blue. And what's going to happen is going to surprise you, and it's going to happen kind of fast. So I want you to be really watching. I'm going to take a little bit of dishwashing liquid. Here's some dishwashing soap. Now this is the part that you have to watch, okay? So watch carefully in here. I'm just going to pour a little drop right in the middle, and I want you to watch what happens. Did you see that? Now I can make patterns
If you wanted to be up here, you should have
by
finished
blowing it
your work.
around, by moving it with my fingers. It'll swirl all around. If I put another bit of it in, what do you think will happen?
More.
You think it'll create more?
Yeah.
It's about the same. There it goes. It's starting to break out that way. So what I'd like you to do is turn to the person next to you and try to figure out some yes or no questions that you can ask me about what's going on. What is happening? See if you can come up with some questions, and you can ask
Water
me.
is fresh and like but you know the water comes from the ocean. So when it goes to the ocean, like it's salt. So the water evaporates and then it makes
So who has a yes or no question that they can ask?
that like the water comes from the ocean, so it's salty. So when you put it there, it like the salt evaporates and then it gets the colors. Then it makes us feel.
That is a wonderful, educated guess. Do you know what we call an educated guess in science?
A hypothesis.
We call it a hypothesis. It means that we think that this is the case, but we're not sure. You just came up with a good hypothesis. Can everyone say hypothesis?
Hypothesis.
Yeah. That means you're guessing at what's going to happen, then you're going to experiment to prove it or disprove it. Might not be true. That might not be the reason. That's a good one. We'll keep that in mind. Salt water. Who else had a yes or no question? Still keep on doing the same thing? Let's see what happens when you put a little bit more. Oh, if I put everything in, do you think it would be different? Yeah, it's still working, isn't it? So what is another yes or no question about what's happening? Anybody else? Okay, I'll tell you what's going on a little bit. talk about something that everything is made up of. Do you have any idea what the smallest particle of matter in the world is? What's the smallest thing?
The smallest thing is salt.
Nope, even smaller than salt. Sand is the smallest? What else? Ants are the smallest? What do you think? Sounds good, small. What? Silt? Okay. Gravel? Okay, so you guys are thinking of small things. They certainly are small. But you know what? Even the tiniest speck of gravel is made up of atoms. Have you ever heard of atoms?
Yeah.
Atoms are things that are so small that we can't see them, and everything, the rug, the air, our bodies, the ceiling, everything in this room is comprised of different kinds of atoms. There are different kinds. Some atoms are of a metal, like gold, might be a gold atom. Some are of a gas, like oxygen in our air. There's atoms in our air. So it's the smallest thing that we can break down other things into. Yes.
Like if you had an atom that's red and yellow, if you break it, it makes an explosion. If you break atoms.
If you break atoms, yeah, it's a real technically difficult thing to do. So it's not like you can just get an axe and cut an atom in half. They have to use billions of dollars of equipment to do that. But an atom contains a lot of energy, and they can get the energy from it, and we can make power. So I'm going to show you one more little experiment using some water. And what I would like, who's got really steady hands? Okay, could you take this to the sink and empty it and put about the same amount of water in this? Be careful. Thank you. Okay, so atoms make up everything, and they are in different combinations called molecules. Everyone say molecules.
Molecules.
Molecules are also extremely small. I can't even tell you how small they are. We can't see them. They're that small. So small we need a microscope to see a molecule. Okay, because it's just a couple of tiniest little things put together. And in water and in liquid, here's what the molecule does. Okay, let's say I'm a molecule. I have a need to attract to other molecules. I don't want to be just floating around in space with nothing. So if I'm a water molecule, my leg is going to want to reach out to another water molecule. And my other leg is going to want to reach out to another molecule. And my hand's going to want to reach out to another molecule. And my hand's going to reach out to another molecule. And even my head. So I want to attach to a whole bunch of other molecules. So let's say that those molecules are the tips of my fingers. Here's the way water moves with molecules. The water has molecules that aren't, watch my hands. The water has molecules that aren't in an arrangement. They're just moving all over against each other. What happens when water freezes? Those molecules slow down and they get into a rigid formation and they stick there. And when water freezes, what do you call it? Ice, yeah. Ice has water molecules that are in an arrangement, and they're all stuck together in a certain way. Water molecules in liquid are free to move all over the place. I can go like that and rearrange all the molecules. They're just moving all over the place. But you know how they're attracted? Like I said, they attract to each other. Well, the water on the top, the very top layer of atoms, it wants to reach up to another molecule, but there's nothing there. It wants to reach up over here, but there's no atoms on top, just air. So you know what it does? It says, I have this energy to reach to that, but there's nothing there, so I'm going to reach to my friend over here, and I'm going to reach to my friend over here, and I'm going to hold on even extra tight. So all those molecules just on the top are holding on to each other really tightly, making what we call surface tension. Can everybody say surface tension? Surface tension. It means that on the top of water, it's got an extra strong hold. And that's why when I put the color in the milk, and milk works just the same as water in this case, it had a surface that the water stayed, the color stayed on top of. But then when I added detergent, the detergent breaks up that power that's holding it all together. It says, I'm going to undo that lock, and I'm going to let all those molecules flow away. And when it happens, the water kind of flattens out, and everything goes to the side. I have also a little bit of, this is dillweed. I'm just going to sprinkle it in here in the water so that we cover the surface pretty much. We've got to make sure the water gets in it. You see how it floats on the surface? It's floating on the surface tension. Now let's watch what happens here. What's your guess? What's your hypothesis of what's going to happen when I put in some, I might have put too much soap. Yeah, put in some soap in this. What's going to happen? The soap will stay on top? Okay, anybody else? You think the soap will go down? What else?
It will evaporate.
It will evaporate. Those are good guesses. Good